Okay, so we are still going to be working with 4.4, but now we're going to be looking at solving an equation with a variable on either side of the equal sign, but we're also going to be using the distributive property, so including just a few more ways to solve some of these equations, and again, it's just building off of what we've already done in the past, so still using the distributive property, still trying to get the variable to one side, constants to the other, and still solving like we always have been, so just kind of building off of what we've already been doing. So hopefully you're getting better each day and each week, because we are truly building and using everything that we've learned up to this point. So we're going to solve the equation for the given variable. So again, you are taking your own notes during this video, so make sure you get all the examples written down in every single step. So if you need to stop the video as we go, do so. So we got the left side and the right side. If you notice, I have the variable on either side. So my goal is going to be to get variable to one side, constant to the other. But if I look at the left side, what do you recognize? What do you see to do? The distributive property. So we first need to simplify the left side. So what we're going to do, we're going to actually use the distributive property and expand this out so we can actually start moving x. Because as of right now, it's kind of trapped inside those parentheses. I can't do anything with it. I would break all kinds of orders of operation. So the first thing I want to do is distribute the 4x. So I have 4x minus 4 times 4 is 16 equals. Now on the right side, I want to do the same thing because the distributive property is there again. So 5 times x minus 5 times 3. So now we have a problem similar to what we were looking at yesterday. Variable on either side, numbers. So the goal is get the variable to one side, constants or numbers to the other. So it doesn't matter what you move first, the x or the numbers, and it doesn't matter which side you start to work on. So what I'm going to do, I'm going to subtract 4x from both sides. Now let's think about why that might be a good idea. Notice 4x minus 4x is 0. I still have my negative 16 equals 5x minus 4x gives me a positive 1x. And then I still just have my minus 15. So I was able to see in advance, hey, I'm going to have 5 minus 4, which is a positive 1, as opposed to if I subtracted 5x from both sides, 4 minus 5 would be a negative 1x. So it just kind of saves me a step at the end where I'd have to divide by that negative 1 to get negative 1x to become 1x. So now, I have the variable on one side, but I still need to move those numbers. So, and also notice that x is already by itself. 1 times x is just x. So how do I do that? I add 15 to both sides. Negative 16 plus 15 is negative 1. So x equals negative 1. So we're finished. We know what x equals. And again, you can always check that by plugging into the original problem. Well, there we go. Okay. So, look at the next one. Negative 13 minus the quantity of x minus 2 equals negative 3 times the quantity of x minus 3. Okay. Have a lot going on the left, have a lot going on the right. Can I simplify the left side at all? Well, I do have the distributive property. Can I simplify the right side? Again, I have the distributive property. So let's first take care of the right side, because that one looks like it's going to be easier to tackle than the left side. So negative 3 times x, negative 3 times negative 3 is a positive 9. Okay, let's go to the left side. So if you remember, this is like having a negative 1 in front. So I'm going to be distributing the negative 1 through. It's the exact same idea as saying, hey, I'm subtracting x and I'm subtracting a negative 2, because you're subtracting everything that is in here. This negative 13 is just hanging out for the time being. I cannot do negative 13 minus 1 because that would break order of operations. I must multiply first before I add or subtract. Remember PEMDAS. So negative 1 times x is negative x. Negative 1 times negative 2 is a positive 2. Okay. So I want to still look, can I simplify the left side? Yes. I have like terms. Negative 13 plus 2 is negative 11 minus x equals, just copy everything else down. All right, so now, variable on both sides, numbers on both sides, get variable to one side, constants to the other. So, I don't know, this time I'm just going to go ahead and start by adding 11 to both sides, just to kind of give you a different look at it. So negative 11 plus 11 is 0, negative x equals negative 3x plus 20, 9 plus 11. So now I'm going to add 3x to both sides because I have the number on one side, but now I want to get the variable to another. So negative, remember there's a 1 there, plus 3x is 2x equals 20. Divide by 2, and x equals 10 because 20 divided by 2 is 10. So again, the distributed property, continue to simplify left and right side, get the variable to one side, number to the other. Multiple ways to do this, I'm just showing you one route to take. But if you did it and you still got 10 in the end, you're good to go. And we can discuss those ways or different approaches that you took tomorrow in class. Let's look at another one. Okay, 9 times the point of a plus 3 equals 30a. So again, if I look at the left and right side, I have a variable on both sides, so get one variable to one side and the numbers or the constants to the other. I can't just jump in here and try to start to take away that a because it's trapped inside the parentheses. I would first have to multiply it by 9. So let's do the distributed property. 9 times a is 9a, plus 9 times 3 is 27 equals 30a. Okay, so now, what do I want to do? It makes sense. I've already got the constant to one side. I don't have a constant on this side. So it makes sense to move a such that it is on one side. So what's going to enable me to do that? Subtract 30a? No, because I don't have a and my constant on one side, and that would be equal to 0, and then I have to move things again. So to get a to one side, because the constant is already by itself, or on one side, I'm going to subtract 9a from both sides. 9a minus 9a is 0. I am left with 27 equals 30 minus 9, 21a. So now how do I get a by itself? 21 times a, so I divide to undo that. So a equals 27 over 21. Can I reduce that? Yes. What goes into both numbers? 3. 27 divided by 3 is 9. 21 divided by 3 is 7. So a equals 9/7. Or 1 2/9, however you want to write it. I like my improper fractions as long as they're reduced. Okay, another one. Left side, right side. Can I simplify either side? Do I have a variable on both sides? Yes and yes. So what does it look like I have set up to do here? The distributed property, so that's exactly what I'm going to do. 3 times 4x is 12x, plus 3 times 2 is 6, 2 times x is 2x, plus 2 times 1 is 2. So again, what's the goal? Variable to one side, constants to the other. So I've expanded this out, I've written it in a form such that now I can start to manipulate the equation and get x by itself. So, I don't know, I'll start with subtracting 6 from both sides. So I have 12x, 6 minus 6 is 0, equals 2x. 2 minus 6 is a negative 4. So I've got my constant to one side, I've got to move the variable to one side. So let's go ahead and subtract the 2x from both sides. 12 minus 2, so we've got 10x equals, that's 0, negative 4. So what do I do to get x by itself? It's 10 times x. Anything divided by itself is always 1. Excuse me. So 10 divided by 10 is 1, so I have 1x, or x equals negative 4/10. But again, I want to make sure that my fraction is always reduced. So can I reduce my fraction? Yes, because 2 goes into both negative 4 and 10. So negative 4 divided by 2 is negative 2. 10 divided by 2 is 5. So x equals negative 2/5. So what makes this equation true? When x is negative 2/5. And just like always, every single step is equivalent to this original problem. They all represent the exact same equation. They are just, each step is just written a little bit differently or in a different way. All right, last example. So going back to clearing fractions, I know that we're not huge fans of fractions, so if we can get rid of them, let's. So do I have the distributive property again? Yes, but notice it's a fraction. If I distribute the 1/4 through, I'm creating more fractions. So if I want to simplify this for myself, I can get rid of that fraction by clearing the fractions. So notice the fractions. I have a 4 and a 3 in the denominator, and technically this guy is over a 1. So you want to think of what is the first number that 4 and 3 go into. If you don't know, you pick up your calculator and just start trying to figure that out. Well, 4 and 3 both go into 12. So since that's the first number, the least common multiple between the two, I'm going to multiply both the left side and the right side by 12 to get rid of these fractions so I can work with nice integer numbers. So I'm going to multiply this side by 12. So 12 times 1/4, remember that's 12 over 1. 12 times 1 is 12, over 1 times 4 is 4. 12 divided by 4 is 3. So I have x minus 5. And again, where does this 3 come from? 12 times 1/4 equals multiply the right side by 12. So again, I've created the distributive property again here. So 12 times 1/3, or 12 times 1 is 12 over 3 times 1, so 12 divided by 3 is 4, and 12 times 3 is 36. Okay, and that should be an x there because it's 1/3 x. Okay, so now, nice easy problem again, I just got to do the distributive property one more time. 3x, 3 times x, 3 times negative 5, equals 4x plus 36. All right, what's the goal? Variable to one side, constants to the other. So I'm going to add 15 to both sides. Again, you can start with variables, with moving the variables. You can start with moving the constants. It does not matter. But I have 3x, negative 15 plus 15 is 0. And then I've got 4x, 36 plus 15 is 51. So plus 51. Actually, I don't like, 4x plus 51. Okay. So I've created a situation here in which I've got the constant on one side, I want to get variables to the other. So I'm going to subtract 4x from both sides. So I end up with negative x equals 51. Well, remember, that's like negative 1 times x. So x is still not by itself. It's being multiplied by negative 1. So I must divide by negative 1 to get x by itself. So that's okay if you end up with negative x equals. Just do not forget to divide by negative 1. It must be 1x, 1 times x. X must be by itself, x must be x. So again, distributive property, make sure you simplify, combine like terms on either side of the equal sign. Get the variable to one side, number to the other, using everything that we've learned up to this point. And now I want you guys to try your own problem, bring that into class tomorrow. So this is the equation that you will be doing for me tomorrow. You're going to solve the equation for y. So get that one copied down as well, solve it, and then I'll check your answers when you come to class tomorrow. See ya.